Welcome to the Flight Readiness Review for Autonomous Aerial Vehicles at Virginia Tech. This video will provide you with a brief overview of our UAS and flight testing to demonstrate that the system is refined to a point where it can compete in the 2025 SUAS competition. Our team operates through a collective effort of 9 undergraduate students majoring in the fields of mechanical, electrical, computer, aerospace, and civil engineering, as well as computer science. The team is divided into 2 sub-teams: structures and propulsion, and autopilot and electronics. The structures and propulsion sub-team consists of 4 members, and the autopilot and electronics sub-team holds 5 members. Although all members play a critical team role, the competition team will consist of 3 operators. John Readiness has been on AAV for 3 years, is the team lead, and will be the safety pilot at the flight line. Jan Stanforth has been on AAV for 2 years, is the structures and propulsion lead, and will be in charge of payload systems at the flight line. Shrutika Narharasetti has been on AAV for 1 year and will be the ground control station operator at the flight line. Introducing Grey Goose, a custom quadcopter aircraft capable of fully autonomous air delivery of multiple payloads using an onboard imaging system. Throughout system development, our team has emphasized the importance of safety, testing, and reliability to ensure that all components on Grey Goose are ready for flight. In order to ensure the safety of all personnel, strict guidelines were set in place prior to the development period. In order to gain access to the lab and all the tools held within it, each member was required to take an extensive training course that lasted approximately 3 hours. After completing this course, the members were briefed on the safety risks posed by the development and flight of UAVs. At all times, a safety lead was designated and kept all necessary safety equipment on hand, such as a fire extinguisher, safety glasses, lipo-safe bags, etc. To mitigate the major developmental risks, each individual component was tested before it was added to the UAV. In order to mitigate the safety risk posed by Grey Goose, all personnel were required to stand at least 15 feet away from the craft in flight. As a large multi-rotor platform, Grey Goose poses many safety risks during its autonomous flight and testing. To mitigate risks associated with the craft's proximity to others in flight, each flight always begins with a debrief to ensure all team members are aware of the craft's planned mission. At all points of the mission, a safety checklist is periodically consulted to ensure that the UAS is cleared for flight and reacts predictably during all stages. The table shown on screen outlines a subset of the specific mitigation strategies developed to minimize risk during testing and flights. In the following section, we will demonstrate how this testing has proven that Grey Goose is capable and safe enough to operate at competition. The following flight videos cover the requirements for proof of flight piloted by John Readiness, our safety pilot at competition. Only one instance of Grey Goose exists, hence only one instance of each required flight will be shown. First up is the manual takeoff leading to a 1,000-foot departure and return for landing. Lastly, the shown flight will demonstrate that the drone can meet all autonomous flight performance requirements. These flight performance requirements consist of an autonomous takeoff above 50 feet at ground level, a flight of 3+ miles at full loaded weight in a single flight, flying waypoints with a max error of 50 feet, and a turn radius of less than 150 feet with the ability to meet maximum angle of climb and descent of 20 degrees. Throughout the season, our team worked diligently to create a fully custom UAS named Grey Goose, with the ability to perform autonomous flight, airdrop, and object detection, classification, and localization. Grey Goose is designed and developed around the elements of reliability and redundancy. Numerous flight simulations and tests have ensured that Grey Goose will perform well in the mission demonstration and is ready to safely participate in the 2025 SUAS competition. We look forward to competing in June and showcasing Grey Goose's capabilities.